Okay, good afternoon. I guess we'll get started. So I'm betting that a bunch of you who basically decided to come to this session probably looked at the abstract and said, what's that, right? Edge-free programming. It's kind of odd because I kind of took a very circuitous route to basically get to this particular topic. One of the things that is fascinating about all of design and development is the notion of abstraction. The idea of going and trying to find like the core, the essence of a particular problem, express it. If we do that with a lot of clarity, we can end up having very simple, easy to understand code that's just right for us. In object orientation, we've often had the thing of like, let's find the key abstractions like a reservation or an item or all these other different things, which we try to keep these classes as unsullied as possible. We try to keep them as easy to understand as possible. We often have, though, these concerns that kind of get mixed in. And functional kind of helps us with that. We try to still take our domain concepts and sort of make them the key abstractions within our code. But the thing that's kind of problematic with that is that there are always things that kind of get in the way, right? And this is something which was really embarrassing for me years ago, is to discover that all the time I was visiting teams and being really upset with their logging. I looked at it and I said, hey, I know this is necessary. I know you need to have the logging there, but it's like it obscures the main path of the code. So you see a little bit of computation, logging, a little bit of computation, logging, and then it's all scattered and it's like everything's just mixed together and it's really kind of awful. And the thing is, I never really felt comfortable going and saying anything about this because essentially, we know that it's necessary, right? But I just didn't like the mess of it. But after years of basically feeling this way, I finally ran into a couple of friends, Steve Freeman and Nat Price, and they mentioned a different way of approaching this. They said, when you are doing your design work, if you consider the idea that your system should throw off information, okay, that it should produce information for you in all the context that you really need, then you basically don't have as much explicit logging. It's more like, you design your system to go and kind of throw off events that basically tell you about what's really happening in production, and you consider it a first-class, thing in your design. And to me, that was really kind of a revelation in a way. There are many different areas of programming. If we choose to basically take them very seriously or make them first-class design considerations, things can become much clearer. And so I started looking at this in terms of error handling, right? Because, if you're like me at all, you'll see the same thing with error handling. Essentially, you have some kind of logic, but then it's obscured by error handling. You have try-catch blocks, you have all these other crazy things going on, and it doesn't really adhere to single responsibility principle, any of these other things. You look at a particular method, and it has error handling scattered all the way through it, along with the computation. How is that separation of concerns? It definitely is not separation of concerns, and that's problematic for us. So I started thinking about this and looking at it and experimenting and trying to dig into this topic. And after a while, I started to notice that it's really just deeper than error handling. It also has to do with like the way that we make decisions in code, all the edge cases that we confront day to day. How can we go and get rid of some of these things, right? Or at least basically set it up in such a way that they're not as onerous. So I ended up with this idea that noticeable error handling is a symptom of bad design, and started noticing that as I tried to go and sort of challenge error handling in programs, I ended up with design that I felt was somewhat better. And as I mentioned, conditional logic, you've been here, right? Yeah, so we're going to go in and examine that also. So I ended up with this concept to call an edge. And an edge is essentially a way of disrupting a program, right? It's something which is like a discontinuity in the context of a program. And you can see edges in user interface as well. But one of the simplest edges that we ever confront is essentially go-tos, right? Go-tos are just really kind of like this jump from here to there, and then basically you have all this surrounding context that you kind of lose. You have all this crazy stuff that happens because you can end up jumping someplace where you have different scoped variables, all these other things. If we take another step forward, we can see that, our typical conditions, if, then, else, and all these other things are edges as well, right? These are places in code where we basically make a decision. And then you have exceptions, which are, really nasty edges as well. Throw, an exception someplace, you got to hope that somebody's going to go and catch it, and then there's a lot of context that you kind of lose when you're going from one place to another, a place where you've thrown to a place where you catch. So yeah, edges are points of discontinuity in software, and if we basically keep this idea in mind, we can sometimes arrive at some better things. We've known for ages that complexity is really the enemy in software development. So we have all these metrics from quite a while ago, things like cyclomatic complexity, which again are really all about decision points. So my thesis is that essentially if we can remove a lot of decisions in the code, we can end up with code that's clearer and easier to work with. So I want to walk you through a little bit of a problem, a little simple thing. And I think I gave a talk here last year, and I can use the same example, but I'm basically highlighting it in a different way. A friend of mine in Miami is a classical music composer, and essentially he wanted to go and have a program to go and take text files and basically produce something called guitar tablature, right? And guitar tablature is the notation used by guitarists to basically sort of notate music. And even if you don't know much about playing guitar, it's pretty easy to understand. Essentially, a guitar has 6 strings on it, right? And essentially, you can press the frets. These are all numbered frets from 0 to, meaning not pressing anything, to 1 to like 24 frets on a guitar. And essentially, you can notate like a little melody like this. You basically have the numbers, the finger position, and then you have the strings. And each one of them is like the line that we have here. He wanted to take this from here, okay, to have like an input file, and on every line of the input file, you have a string and you have a fret. And so we can see here it's string 1, fret 0, string 1, fret 5, string 1, fret 3. And you can essentially see that kind of reflected in the notation that's there. So suppose that we have that representation on the bottom, right, a file of 2 numbers per line, and we want to produce the representation that we have on the top. We can write a simple program to do this. But first of all, let's go ahead and imagine all the different things that could go wrong when we're going to, read this input and do things. And so here's a bit of a list, right? If we're writing a little command line program for this, maybe the argument for the file name may be missing. So that's the thing we have to go and deal with. We may be unable to open the input file. We have to go and deal with that also. Maybe the file is empty. What should our program do? Maybe the file contains empty lines. Is that an error or not for us? Maybe the input file is not a text file. That could be a bad thing that happens also. A line can have more than 2 numbers. It can have less than 2 numbers. It could have fields that are not parsed as numbers. String number could be less than 1 or greater than 6. There's basically 6 strings on a guitar, and we want to enforce that. And the last one is the fret number could be less than 0 or more than 24, okay? And that's typical for guitars to go way up to, say, 24, for instance. So how do we deal with all these potential edge cases, right? Well, my idea with this is essentially what we do is we can kind of look at these things and ignore them at first, okay? Just write the main flow of the code. And to do this, I'm going to basically show you just essentially some little Ruby code here. Every one of these particular lines we have kind of maps to a column that we can produce in the output representation. And if you look at the code that I wrote to go and do this, this is essentially what it is. Shock, horror, right? It looks kind of crazy, doesn't it? Jump down to where it says file open. Okay? Essentially what we're doing there is we're opening a file that's given as a command line argument, and we go through each line of it. And what we're going to do is basically each line we're going to split it on white space. Okay? So we have 2 numbers on the line. Basically we're going to end up having an array of arrays, and each subarray is going to be the fret number and the string. There's 2 arrays there. That's what we're hoping, at least. The next thing is we perform a mapping operation that's going to have the string and the fret, and we call tab column, which is going to go and produce that column notation that we have up above. And what we're going to end up with is that we have all these arrays of columns, and what we're going to do is we're going to do a transpose so we can go and get the first element of each column, the second element of each column, and the third, and then basically paste them all together. And we're essentially going string by string instead of going column by column after the transpose. We join all those pieces together, and then we join them with new lines, which is what the $/ happens to be. And we end up having the representation that we print out. So this is a pretty counterintuitive way of doing things. You have to use a fancy operation like transpose to go and solve the problem. But you'll notice, though, that this is extremely straight line code. Essentially, there's no real conditionality to it. In fact, it goes and gets even a bit more extreme. I'm doing something here I call arithmetic encoding. In order to go and produce the column that we have here, notice that the column happens to be like a field of, say, 3 dashes, possibly with a number inside of it for each one of the columns that we're producing. What I'm doing is I'm saying, okay, I'm going to pass into this function a string and a fret, and what I want to get out of this happens to be an array of strings. And every string up to the one that has the fret position is going to basically consist of just 3 dashes. And you'll see the asterisk there is basically taking a number on the right, an array on the left, and kind of like just duplicating that number of times, right? So we basically duplicate, 3 dashes a certain number of times up to the point where we have the fret. Then we do the fret case, and then we actually go ahead and do all the remaining ones. And so again, I'm avoiding an if condition in doing this. It's a little bit alien in a way, but it's kind of like just sort of like also encoding the problem in a particular format. So we're doing this, but there's also some conditions that remain in this. We have this right here. Unless this file exists, we're going to print an error message saying we're unable to go and open this file. So can we challenge these things? Can we challenge these conditions? Well, turns out you can, okay? If you're working in Ruby, one of the things you have available to you is a thing called argf, and it's really a variable that goes and gives you every file that's given to you on the command line gets concatenated into a large swath of text, and you can just treat it as like one big block of text and just rip through it. Turns out this actually works out fine if you give nothing as an argument also. You'll just get an empty string, and the empty string can pass through all these stages and just produce nothing for us. So we've removed an error check, and we actually sort of like changed the requirements a little bit, but that check is gone, and we also have the ability to just like run to completion in a nice way. So of the things I mentioned earlier, I kind of cut out a bunch of them. We don't have to worry about the command line argument missing. Don't have to worry about not being able to open an input file. It's just going to go and do the nice thing. If the file is empty, it does the nice thing anyway. But we still have these other things going on here, right? And we can do something about those. Well, let's look at one of them, okay? Notice the one that says number 6, a line has less than 2 numbers. What we could do is we could say, let's allow ourselves input like this, right? We could say, let's go ahead and say that if the second number is missing, we'll basically go and say it's 0 by default. Is this a good idea or a bad idea? Bad. It's interesting. It depends, right? And it's like, I think that's the answer to just about everything. It depends. But this is something I call a domain extension. And we see this in many different areas in programming, and it's a two-edged sword in a way. So everybody knows the square root function. It's available to you in C and every other language. Are there any values you can pass the square root that just don't work? Yeah, -1, right? You get imaginary numbers and such and such. Could we create a square root function where you could pass negative numbers into it? Yeah, we could return back complex numbers, but then we'd make the rest of our application more complex, excuse the pun, right? But the thing is, we do have that option. What we can do is we can increase the range of things that we're receiving, and it can work out fine for us if we choose to go that way. We do that in other places, like for instance in Python and in many other languages. If you give a list a negative index, it's not an error. What does it do? It starts giving you values off the right-hand side of the list. Is that okay? Yeah, see, here's the thing. You can extend a domain, right, in order to go and basically accommodate, things that are, just sort of like saying, hey, this is permissible, this is permissible, this is permissible, we're using defaults. But the thing is, when you do that, you have to basically sort of bear in mind that there's also the chance of an error, if people don't understand what the convention happens to be. So it's possible that somebody could go and sort of like somehow wrap around an integer, pass it into a list, and sort of do something crazy. They think that they're going and indexing from the left, but they're indexing from the right because of the fact they wrapped around in integers. But very remote chance, and everybody kind of understands this is the convention. You can use negative indices, and it works. So I think it's kind of good for us to go and think of this in terms of, it's kind of like a language for us. Essentially, we get to decide what the APIs are, and if we can basically make sure everybody understands what the APIs are, then being a bit forgiving can be okay. So for instance, this could be okay if everybody kind of understands that. If somebody goes and accidentally forgets the second number, that could be something which is really counterintuitive as a result because, it really has a meaning for us now. So we have that. I'm going to drop off our input file. It's not a text file because that's just going to be an error that goes and throws an exception and something, and we'll be able to deal with it. But here's like another way of going and tackling most of the other things we had listed as errors. What I'm doing now is I basically start out in the beginning and I say, I go to argf, I get each line, and I'm going to select all the lines that are not blanks, okay? And then I'm going to split all those things. Split it so I have like the string and fret number, and I'm going to call that my line representation, my lines. Then I'm going to have a series of checks, and each one of these checks is going to go and basically verify that we are, these bad things haven't happened, and we can go and, emit an error message if they have. So check, 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 check all the way down. By the time we get down here to the put statement, okay, the very bottom where we're going and saying, from these lines, let's go ahead and do all these different things, things are pretty good in our input. We pretty much know that everything is going to go and work. And I think this is kind of a key thing, that I mentioned earlier that error handling is something which can become really crazy if it gets embedded all through the logic of our programs. It's nice when you can to go and set things up so that the error handling happens at the edges, and then once it's happened at the edges, basically you know that once you're past the edge, everything is good, and you can just run to completion. You don't have to do very many checks at all. And this is kind of where we are with this particular situation. What we've done is set it up so that we can, essentially, once we have everything broken down into these things, we verify that the integers are what we need them to be, we can do the processing we care to go and do. There's something else here, too. Oops, it's this right here. There's a little saturate function here. You see what I'm doing? I'm saying the fret number should be saturated to between 0 and 99. And I could have said that if the fret number was higher than 24, it's an error, right? Because I said earlier that fret number should go from 0 to 24. But here what I'm saying is that essentially, if the fret number goes beyond 99, I'm just going to go and make it 99. Saturate at that high end. Is that a good idea? Yeah, and that's the thing. So some people here who are guitarists or play string instruments will recognize that, it kind of varies, how many frets you have in some stringed instruments. So we want to leave it a little bit loose here and say, okay, well, we'll allow you to go and have more than 24. The thing that we know, though, is that once we go past 99, it's going to really mess with our, going back here, notation, because we're in a field of 3 dashes. So once you have 100, all the numbers are going to kind of like run into each other in the representation, and that's not nice. So we're guarding there, but we basically feel like, it's not such a big deal that we want to go and actually, stop processing or whatever. And we never really anticipate that people are going to go beyond 99. A stringed instrument with 99 frets would be crazy. It's just not going to go there. So rather than going and troubling people with an error, we do this. And we also know that on the output end, if somebody sees a 99, it's like, if they put in 101 and they get a 99, they're going to recognize there's a problem, right? So we're okay doing that. So saturation is another way of going and sort of guarding a particular area within the code, but you have to be aware that when you do it, it has to be okay on the other end. So what we're ending up here with is this. Essentially, we have done all this checking in advance, and then we have this area down below where essentially things just work, okay? And this is the thing that I really think that we need to strive for more in programming. And I kind of see it in this way. It's kind of like we can imagine any area of our system as basically being something which is a boundary surrounding some area where you don't have to do very much checking at all. It's interesting to note that this idea has been around in different forms. We're seeing more and more of this notion of an edge across the industry. There's kind of like the functional core and imperative shell. There's ports and adapters that Alistair Coburn had come up with. One of the things I find is fascinating is that we're getting closer and closer to seeing all this stuff in terms of errors also. Everybody know who Bertrand Meyer is, right? Okay, early object orientation. One thing that he wrote that I still can't find exactly the quote for, so I'm paraphrasing, is this. He was talking about exceptions and when to use them in programs. And he said, use exceptions when you can't know in advance whether a call will succeed or fail. When is it that we don't know in advance whether a call is going to succeed or fail? It's usually just I/O, isn't it? Right. And if you look at functional programming, there we have like, in Haskell we have the idea of the I/O monad, where essentially it's like the outer frame of the application where I/O can occur, but once you're past a particular point, you can, just be in pure functional code. And that's cool, but there's also this corollary to this. Essentially, once we get past those particular errors that can occur at the edge, we should be in a place where we can just kind of run to completion. We don't really have to do much checking at all. So, protective shell, soft center, trusted zone, it should just work. Kind of like candy. Anybody hungry? Right. So the big thing becomes how do we form this shell that basically goes and sort of serves as the outer layer of some context within our programming. And we have tons and tons of different possibilities for this, right? One of the things that I think is most problematic for us in the industry is that when people talk about error handling, they quite often talk in terms of mechanism rather than design. In the earliest days of programming, we had just the idea of return codes, and some of the C code that you've seen out in the field was probably scattered with, like, we make an API call, we check the return code, we hope that we do, and then we are kind of like mixing the thing that we're trying to do with all the error conditions, and that's kind of the place I hope that we wouldn't want to be. Error monads have become far more popular now. You have option types in a variety of different languages that allow us to go and do very cool things. Exceptions are a good old standby. We've been using them for ages within the industry. One error mechanism that people don't talk about all that much is something called condition systems. They were kind of like built in Lisp, and I just haven't seen them really push into the industry very much. But the idea behind this is that you can kind of have something which is almost like an exception that you throw, but what you do is you basically say, when this particular thing happens, execute this particular code, right? So you can almost like parameterize an area of code by a strategy that's going to be executed when a particular error occurs. And even though languages don't tend to have condition systems built into them, we can go ahead and use the strategy pattern, for instance, to plug in the things that we want to go and have if we want that kind of capability. So let's go and look at exceptions for a second. Look at things through this model. So here's some Java code, and we basically have something called a line counter. It counts lines for a particular file. Typical thing, we're putting an exception around this. Good idea? Yeah, we can. I mean, that's fine. The only thing about it, though, is it's kind of like, in a way, a line counter is kind of mixing some computation, albeit trivial, with some I/O operations, right? So that's kind of odd. And what we can do is try to push things deeper. How do we get close to the I/O? If we look at the count lines function on line counter, we see that we have, essentially a reader that we create, okay, which is going to work against the file that we're opening. And then we have all these read line operations, and then we close the file. So what can go wrong here in terms of going interacting with the outside world? Well, for the most part, it's opening the file and actually going and doing the close. The way that API in Java works, essentially a read line will just return a null. If there is no line there, you don't have some kind of like an I/O exception thrown. But essentially, how do we sort of like separate the computation, which is really the counting of the lines, from the actual I/O here? And the thing is, it's kind of hard to do. We could try to sort of like pass a block in or something like that, but it'd be a bit crazy. Well, here's another option with this. Can we say in our domain that a non-existing file has a line count of 0? Okay? And this is a really interesting thing because it feels dirty. It feels kind of bad in a way. But depending upon the context, it could be possible for you. You could just go ahead and say, well, I'm just kind of like doing this thing where I'm going and searching across all my files, and if there is a malformed file name or whatever, that's okay, because I can just go and say the line count for that thing happens to be 0. And it really, really does depend upon the domain whether you can do something like this. But we can do that in our code and say something like, well, instead of going and sort of like mixing our computation with our error handling, we have an outer area which is going to go and do this work, and essentially if anything goes wrong, we just return a 0 back. And then our processing can continue as normal, and we just don't have to be aware of that condition within the core of our code. In a way, this is kind of like domain extension that I talked about a bit earlier. But again, sometimes it just doesn't quite always work for us. You ever hear of the null object pattern at all? Okay, so it sounds like many of you have. It's one of those patterns that has kind of like a mixed history. It wasn't really part of the original design patterns that were first outlined in the industry in 1995 or so. But it's a good pattern. You can basically use it with various caveats. Idea here is essentially in OO, you have something which is using an object, but you have something else which stands in this place and represents the absence of that object. It gives you behavior that seems normal in context, even though it's kind of like swallowing an error in a sense. One case that I ran into years ago that I could use null objects in a nice way was in the design of a little IDE. I was working on an IDE for Python, and what I kind of noticed is that you're in this situation quite often where you click on, say, a class name and you want to go and see all the methods for it, and then sometimes you aren't really selecting a class name at all, so you'd have to have a reference to the class that would be a null reference. So you have to go and check and see, is this thing null or not? And the idea that I came up with is, let me go and put a null object in place when I'm not selecting anything in the class pane. And so essentially, if nothing is selected, then you still have some good behavior, because you always go to the object that represents the class to get a list of the methods. the null object for representing a class can just return an empty list whenever you ask for its methods. So no checking needs to happen. You just sort of say, hey, I always go to the class object and ask it for its methods. Sometimes I don't have a class object, but I have something in its place that will return to me just an empty list of methods. And so no checking is really involved. But there really are many cases where the null object pattern doesn't quite work for us. And there are other cases that it does. We can see empty lists as null objects in functional programming as well. Sometimes you just try to do something and you represent absence by an empty list. A place where this doesn't quite work so well is, say you're working on like a point of sale problem or something like this, and you try to scan at a grocery store, you scan items and such. And when you do, it's like you say, well, there's something I scanned and it just doesn't exist in the inventory. What do? Well, one thing you could do is say, I'm going to throw an exception. Okay, and that's some high level of the program is going to go and have to detect, catch that exception, and then you go and you do something with it. Another thing that you can do is go ahead and say, well, I'm going to return null. Then you have to go and check for the null and make sure that everything is okay. A third thing you can do is say, I'm just always going to return an item back. And even if the scan doesn't work, I'll just have an item that represents the absence of an item for me. So basically, it'll return 0 as its price. And when you add everything together, it just goes and doesn't affect your output. But the thing about this, though, is if there's any point in your program that really needs to know that you weren't able to find something, you've kind of swallowed that, that particular error in that particular context. So some places it works, some places it doesn't work. But a key idea behind this is that if we're trying to catch errors at the edges, we want to set things up in such a way where the rest of the software doesn't have to go and basically know about them. And this kind of precondition, okay, for a system is something that we don't really take care of often enough in our work. So if you look at this C# code here, you'll probably notice that there's a lot of null checking going on here, right? Anybody know why the null checking is occurring? Yeah, it's kind of funny. And some people just consider it good practice to go and check for nulls, right? And in the days before we really were using option types and stuff like that, it was very, very pervasive. It still is pervasive in many applications. But the thing which typically happens, which causes this, is you have some code, and then basically suddenly somebody goes and gets a null pointer exception in production, and they say, okay, let's fix this. So what do? You put a null check in, right? And you end up having all these null checks. And then people see the null checks, and it's like, oh, this is the way we code, right? And they go and keep on adding null checks and null checks and null checks. But this code is ridiculous, right? Having all these null checks. The thing about this, which is really problematic, is that when you pass null to a function or you return null from a function, what you're doing is you're imposing work on the next context. Okay, if I pass null into a function, what I have to do is basically have somebody check to basically make sure that everything is okay. And this is really, really problematic, and you can actually see an extension of this particular problem across many different domains. A common thing with this also is like I have a custom string format, and I basically format things in particular ways, send it to another part of my system, and then I decode the string in order to figure out what to do. So I'm basically pushing work onto a further part of my program. Here's another case which is like this. You ever see like a giant method, and then you set a bunch of Boolean variables up at the top, and down at the bottom you check them to figure out what you're going to do. Anybody ever see methods like that? Right. So you're creating work up here that you have to go and manage down here. And so it's really a common problem that occurs. And I think that's one of the things that we really need to go and pay attention to if we want to go and remove edge cases, is trying to get things into a good state such that we don't have to do much checking. And once we're in that good state, then we can kind of march on and do our processing without all this craziness. So some of these things happen accidentally, some of them happen as a matter of convention, but we want to try to remove as much checking as possible from our code. So I call that tunneling, when you basically go and create work for yourself later in the context of some code. So here's another thing too. I was showing all that stuff earlier where we're going and doing these checks to make sure that everything's going to work out okay. Here's a more monadic approach to going and doing this work. Essentially what I'm doing is I'm setting up an either monad here. And Ruby doesn't have any of these things built in, so I had to build one myself. And what I'm able to do then is essentially every time I get a line, what I do is I basically perform the computations and then I perform these checks. And what I'm doing is I'm passing between each of these stages something which is either a cumulative error message or basically the computation that we care about for the next stage. So at the very end, when we print something out, it'll either be an error message or it'll be the stuff that we care about. So this is another way of going and separating those two concerns, kind of pushing things through. So yeah, this is this model of going and saying we tackle things at the edges as much as possible allows us this center where everything can kind of work out okay. But there still are cases where we introduce a lot of conditionality in programs accidentally. And if we think it through, we can actually arrive at models where we don't go and do that kind of checking quite as much. Let me go and give you another problem entirely. Music players, right? Every music player you own has a shuffling mode, right, where you're going and shuffling things. And let's think about a naive implementation of going and doing shuffle mode in any particular music playing application. So we end up having like our entire list, our track list of songs, 0 to n. And then we say, wow, let's see, in pseudocode, what we can do is we can basically go and pick a random number, okay, for our next track, and basically use that to, figure out which track to play next. That's okay. Are there any problems doing this at all? Yeah, you can get repetitions, right? So what you could do is you could say, okay, well, if I get the same index twice, what I'm going to do is I'm going to basically do it over again, which could lead you to a loop, right? So let's go and have a little loop here and basically say, okay, we're going to go and get the last one and get one, and basically if it's the same as the last one, we're just going to keep doing it again. Any problem with this code?
You still get patterns.
Sorry?
You still get patterns of songs that, like you could get the same song 5 times.
Yeah, you could. So it's like it doesn't quite deal with that. And it's funny. It's like it's a strange thing about mindset with this kind of stuff that sometimes you say, oh well, this could never happen. It could never happen in a universe. But suppose your random number generator goes and returns the same value 10,000 times in a row, right? We're stuck in that loop, and it's like we know that will never happen before the heat death of the universe, right? But still, it's sort of like it aches. It's kind of like, ugh, don't want to do that sort of thing in the code. So what do? You introduce a little bit more logic. You say, oh, okay, well, let's go and see if it's the same as the last one, and if it happens to be the same as the last one, let's just go and bump up our counter, modulo the list, and go and do these things. So we've introduced more complication in all this, haven't we? Conditionality, modular arithmetic, all these other things. And this is all to basically prevent duplicated, basically the same track happening twice within the context of this. So, we could look at this as just being par for the course, and most of us coding this would be okay with this kind of solution, I suppose, right? But there's an alternative, and basically the key to seeing this alternative is basically feeling comfortable, going back to people and saying, well, what if we do this instead? And not at the design level, but really at the requirements level, okay? So the original complaint was that essentially the same track could play twice. What if we basically go and say, well, how would you like to go and have a music shuffling system where essentially no track is going to play until the entire rest of the list plays? You won't have duplicated across. You're just going to make sure you have a unique path through all the different, different things that happen to be there. Would you do something different then? And if the business says, yay, that's good, I like that also, that's great, then we can just do this thing of saying, okay, well, what we'll do is we'll copy over the list, okay, and then we'll basically, randomize it, and then basically pull off, one each time. And essentially, once we get down to the end of the shuffled list, then we can start over and do that over again, right? Okay? Simpler? Yeah, right? And see, here's the thing that I think is very powerful about all this is we can choose to essentially, renegotiate requirements, reframe problems, and all these other things in order to reduce conditionality in code, okay? We can also do the thing I was mentioning earlier about the saying, let's go and have a default value for the frets in that particular tablature example, and play with these things simply to remove conditionality and also error checking in the code. And it might feel like we're doing this just to make our lives easier and that this is kind of selfish and not really worth the trouble. We're trying to create clean code a little bit at the expense of changing requirements a bit. But I don't think that's really bad, because when you look at it, complexity is really the enemy here, right? We're charged with going and adding so much in terms of features to systems that it's okay for us to go and actually say, hey, this is kind of like, what about this? And if you keep the code simpler, then, you're able to go and basically increase its, its durability over time. You get more features if you keep it simpler, right, over the long haul within development. So That's it. I think that I kind of marched through things very quickly because I wasn't really sure how much time I would have with this. But I think the main thing I want to go and basically press across with this is that when you are doing this kind of work, it pays to kind of think about doing the simple thing to go and solve the problem and thinking about all the different things that you might consider to be edge cases and saying, what if that thing didn't have to be here, right? Do the simple thing and then choose to go and impose the edge cases later as you need to. And that's kind of like, that's the model I'm using quite often in my programming now. It's just, let's go ahead and sort of like just try to do the main course and then impose edges later. And I think that entire practice of going and choosing to challenge these things, is a pretty powerful way of going with it. So wow, I am done way early. But I want to open it up now. Are there any questions or thoughts about this? What if requirements are set in stone? Well, then you're in trouble, right? No, it limits what you're able to do. But I think this is a wide topic. I think that even if requirements are set in stone, there are areas you can basically go and check for, to make sure you sort of like, this is handled at the edge, the center doesn't have to care about this particular thing. You will end up with code which is more general in the center, but you can have less checking and be easier to read and easier to work with. Okay, what do you think about the go way of handling errors? Error handling is very visible. I think that's great. One of the catchphrases I have about exceptions now is that the best thing about exception handling, or exceptions, is that they allow you to put some distance between the point of detection and the point of action, right? That's also the worst thing about exceptions, is they allow you to put distance between the point of detection and the point of action. And I think that with exceptions allow us to go and interleave computational code with error handling to an extraordinary degree. So I do have some respect for the way that Go has chosen to do these things. It really does kind of push that stuff towards the edge. You can panic or you return back almost like I call them like naked monads, because you return back the computation plus the thing that you detect as an error. Yeah, other questions, thoughts? Really? Okay. All right, well, thank you very much. Yep.